Alright, so Courtney deposits $2,000 at 8% annual interest compounded continuously. How long will it take for the account to earn $1,000 interest? So on this guy, we're talking about the keyword here is continuously compounded interest, which is going to be the formula P-E-R-T equals the amount. And so the amount on this first problem is going to be $1,000. In interest. Okay. The percent, the R is 0.08 because we're going to need it as a decimal. And the initial deposit, the P, is 2,000. Okay. So the question is, how long will it take for the account to earn $1,000 interest? Well, my $1,000 of interest is going to be, if I added that in on top of my initial deposit, that would give me the total amount of money that I want. So I'm looking for something that gives me $3,000. Okay, so the question is, how long will it take with continuously compounded money to take my $2,000 and make it $3,000? So plug all this stuff into your calculator or into your formula first, and then we'll need our calculator to help us get a decimal answer. So what I'm going to have is 3,000 equals the initial amount, 2,000, times e to the 0.08 times t. The question here now, the question is, how long will it take? So that's a time issue. Okay? And now, once we get it to this point, what we want to do is get the e part all alone. So divide everything by 2,000. Alright, so that gives me 3/2 equals e to the 0.08 t. And then there's no way to actually solve for t when it's in the exponent like it is currently shown to us. So what we have to do is rewrite this guy, instead of having it in exponential, as a natural log. And the reason it'll be a natural log is because the base is e. So when this gets rewritten as a natural log, it's going to change its look a little bit, and it's going to become the natural log of 1.5 or 3/2 is equal to 0.08t. Now remember, a logarithm is equal to the exponent. So our exponent in this case is 0.08t. And then the last little step, it's a real easy one. How do you get that t all by itself? Divide by 0.08. So punch that into your calculator. And since we're dealing with logarithms, we usually want to carry through at least 3 decimal places, and sometimes 4, depending on how much work we've had to do. But for sure, we want to list 3 decimal places. So punch that in. And I got 5.068 years. And that is how long it's going to take our investment to go from $2,000 and earn $1,000 of interest, so that our total investment is $3,000. Okay, so now we've got a scientist who is given a piece of fossilized tree, that should be trunk, not truck, that is thought to be over 5,000 years old. The scientist determines that the sample contains 65% of the original amount of carbon-14, and we want to try and determine, is the age of the tree actually going to be larger than 5,000 years old? Is that a good guess? So the half-life formula that we're going to use on this, because that's what we're dealing with carbon-14 as a half-life. And it looks like this. F equals S times 1/2 and T divided by K. And the F is your final amount. Okay, your final amount, F. And in this particular one, we've got 65% of the original amount. So we don't know how much we started with, but we've got 65% of the final amount. So let's go ahead and we can just call that 0.65x, which would represent 65% of how much we started with. Okay. The S is your starting amount. And again, we aren't told exactly how much we started with, but we know that at the end we have 65% of that left. Okay? The T is time. So in this case, T is going to be 5,000, because we're guessing that this is going to be a 5,000-year-old tree. And then the K is the half-life time. All right. So K is the half-life time. The half-life of carbon-14. The half-life of carbon-14 is 5,570. Okay, and what that means is it takes 5,570 years for half of a sample of carbon-14 to decay. So let's say we had a sample of carbon-14 that was like 10 grams. 5,570 years from now, that 10-gram sample will now be 5 grams. Okay, so that's how half-life works. So we've got everything in here. We've got everything we need except for x. And so we're looking for x to make sure that the starting amount is a number that makes sense. Okay, so we can set all of this up. 0.65x equals x times 1/2. And the time, we're told, is 5,000 years, divided by the half-life, 5,570. So the first thing that we notice, that this is x times 1/2 to the 5,000 divided by 5,570. So the first thing that we need to do is divide both sides by x and get rid of the variable. We can't add or subtract here because our x is multiplying, and in order to move it away so that we can start doing other things, we have to divide. Well, look what happens. What happens when you divide by x on both sides? Okay, the x's completely go away. So now we're just left with an equality statement. The question is, does 0.65 equal 1/2 to the 5,000 divided by 5,570th power? So punch that 1/2 to that power into your calculator. And if we don't get something really, really, really close to 0.65, we can't do it. Okay, when I punched it into my calculator, I got this guy equal to 0.537. 0.537. So what this is telling me is that something is incorrect with the age of the tree. Okay? Because based on the information that I've been given about the tree, which is that it's about 5,000 years old, based on that information, I should only have about 53% of my original sample left. So I've got more than that, which would indicate that the tree is not as old as 5,000 years. Okay? So to justify my answer, these two guys would need to be the same. Okay, so the percents do not match. The percents do not match. So the tree must be less than 5,000 years old. Okay. Alright, a skull is found at an archaeological site that contains 250 milligrams of carbon-14. The sample originally contained 800 milligrams of the isotope. If the half-life of carbon-14 is 5,570 years old, find the approximate age of the skull to the nearest 100 years. So if you'll look at the top of your worksheet, we have a half-life equation. And that half-life equation looks like this. F equals S times 1/2 to the T divided by K power, where F is the final size. Okay? F is the final size of our sample. So in this particular problem, a skull found at an archaeological site contains 250 milligrams. That's our final sample. The S is the starting size. The S is the start size, and so they're telling us that that sample, like they I guess have seen these types of things before, was originally 800 milligrams. Okay, and so then the time is what we don't know, and then the K is the constant of decay, and with carbon-14, we like carbon-14. It's used a lot for dating samples because it's so accurate. And so the half-life of carbon-14 is 5,570. Now, here's the deal. A half-life just simply means that it takes 5,570 years for half of your sample to go away. So if I've got a 10 milligram sample, 5,570 years from now, it'll be a 5 milligram sample. That's all I had. That's all it means for that part. Okay. So we're just going to plug all this stuff into our handy dandy equation, which means that we're going to have 250 equals 800 times 1/2 to the T over 5,570th power. Okay. Now, very important to recognize that this number right here is different from this number right here. Those are different numbers. Okay? They're not the same numbers. They are different numbers. And so what we've got is blue times yellow. And if I'm trying to solve for T, then what I'm going to do is divide both sides by that blue part. So I'm just going to take and divide both sides by 800. Remember, it is 800 times 1/2 to a power, not half of 800 to a power. Okay? So pay very close attention to where your exponent is. Alright, so punch into your calculator what 250 divided by 800 is. And I got 0.3125. And that's going to be equal to 1/2 to the T over 5,570th power. Okay. So since T is in the exponent, okay, there's no way to actually solve for it. Okay? Since T is an exponent, there's no way to solve for it. However, we can rewrite this problem as a logarithm. And when we rewrite it as a logarithm, we can actually get the T all by itself. So check this out. When I change this and convert it to a log, I've got a base right here of 1/2. And a logarithm is always equal to its exponent. So the log of 1/2 is going to be equal to T over 5,570. And that leaves the 0.3125 to go into the middle. So how do you get T all by itself? Multiply both sides by 5,570. Alright? And this should tell us how many years old the skull is. So punch all that into your calculator. You may, if you have an older calculator, you may have to do the change of base formula. But I got 9,346.86 years. If we go 3 decimal places, it would be 0.861. And this is how many years old the skull is. Okay, so Marla deposited $8,000 in an account for which the interest is compounded continuously. At the end of 1 year, interest in the amount of $410.17 has been credited to the account. What is the annual interest rate as a percent? So we're going to use the P equals the PE to the RT formula here. Anytime you have continuously compounded interest, then this is the formula that you're going to use. Okay? A is going to be the amount that you have earned. Alright, so this is the amount that you've earned or gained or would take out of the bank. P is the amount invested or the initial amount. Or the first deposit, initial amount, your starter, whatever. Your R is your interest rate as a decimal. And then your T is time in years. So when we fill all this stuff in, it really isn't too bad. We know that we deposited $8,000. We know that the interest that we've received is $410.17. So that means that if we've earned that much in interest, that the amount of money that we have in the bank is our starter amount plus the interest. So we're going to call this, the amount earned is going to be $8,410.17. We know that the time in years is 1 year, and so the only thing that we don't know is the interest rate. So we can go ahead and set this guy up. 8410.17 equals 8,000 times e to the rate, which we don't know, times time, which is 1. So it's just going to be e to the r. And we like that because that's not going to be a challenging thing. Okay? And then we need to get the e to the r all by himself. We need that guy all alone without anybody else next to it. So divide both sides by 8,000. Okay? And when you do that, when you put in your 8410.17 divided by 8,000, I get 1.0512. We'll go ahead and leave it as that. Equals e to the r. And then since the r is up in the exponent, there's no way to get it out like it's written. Like we can't just solve for r how it's written. So what we want to do is change the base. And when we change the base, we're looking down here at this e. Well, any logarithm with a base of e is a natural log. So we're going to have the natural log. And remember, a logarithm is equal to its exponent. Okay, a logarithm is equal to its exponent. So I'm going to have the natural log of 1.051. And so punch that into your calculator. And this will give you out the percent rate as a decimal. So I got that r equals 0.0497. So what interest rate is this really? 4.97% interest on our investment. Okay?